All right, so here we are, day one of a new semester, and we're looking at our first lecture on a new topic, which is an introduction to web programming, ASP.NET Core MVC. And so what I really like about this class is that it takes what you know is C#. I would say we had a pretty intensive semester on C# already, where you guys solved some pretty good challenges, you know. So you guys took C#, but you learned desktop applications, and desktop applications have been going by the wayside for some time. Now they've actually made a little bit of a comeback with things like Discord and Microsoft Teams. There are some pretty big softwares out there that are desktop apps, but by and large, application software today is web-based. And so what I like about this class is it takes the foundation that we all have in C# and it makes it really applicable to the real world and building real world software. Because most real world software today is going the way of the web. And I know many of you kind of have like that passion for C#. You know, maybe you learned it from a young age, and you feel really rooted in C# because it's been around a while. It's been around, really since the early 2000s, and has been gaining popularity, and so I would think you would be excited to get into this. Additionally, when comparing this to the semester that you guys just took, you just learned a bunch of JavaScript. And while the MERN stack is, like survey data would show you, more popular than .NET, any industry is not just job demand, but it's also supply. Any industry is both supply and demand. And so while there's a lot of demand, there's a higher demand for JavaScript jobs, I would also argue that the supply of JavaScript developers is much, much higher. Okay, so I actually think there's an interesting opportunity for you guys, because my perception is that the demand is very high in the realm of .NET jobs, but the supply is not as high, right? The demand is high, the supply is a little bit lower, right? So I would actually, we're in St. Louis, Missouri, and St. Louis is slower to change than like New York and San Francisco. Like, they adopt technology a lot faster. And the Midwest is a little bit slower. And so for that reason, there's a lot here in St. Louis. There are a lot of opportunities in St. Louis for .NET developers. Arguably, a better situation for you guys than even the JavaScript class, even though the job demand in the JavaScript class is so high, right? But there's also a high supply. So it's high supply, high demand. This is, I think, high demand, lower supply. So there's a lot of reasons, I think, to be excited for this class and what this is. And again, it's real world software. Last semester, I found it really interesting. I had a student that had an internship that was literally what he would learn in this class, and was going on the internship and applying it on the job. Like, as soon as he would learn it, he could apply it. And I thought that was super cool. And I already had that happen in this class. There's a student in this class who's like, man, I can't wait to get into this, because what I'm going to learn in this class, like, I already know, my employer told me I will be using it like in the near future. So like I said, real world stuff, and that's kind of cool. Now, some of this stuff is theory, and it'll be a review for you in this chapter 1. If we get into like the objectives and actually what we're learning, like, I think the components of a web application, the client, the server, So some of this will be a review, the parts of a URL. But frankly, it's good to review this stuff too, right? Even though it's review, it's like, let's make sure, even though we might have a foundation, let's make sure we understand these basics. Understanding the difference between static web pages and dynamic web pages. Understanding the difference, that fourth bullet there, internet versus intranet, okay? One letter difference, but it can kind of mean some different things. We're going to talk about standard, client request and server response, HTTP request and response. You guys know this stuff. You just went through the JavaScript class. Remember the rec and the res object, remember? So you've seen that. And the idea of a round trip is like, hey, the client says, give me something. The server responds with something. That is a round trip. He goes to the server and it comes back, right? That's a simple round trip. Then we get into bullet 6, which is some new stuff, right? Describe the model view controller pattern. And I will say the terminology is new, but we implemented this pattern unbeknownst to us last semester. And so, the language is new, and we're going to follow this pattern like all semester, obviously. But we've actually done this a little bit before, and I'll relate how we've done that. And then talk about some of the benefits of MVC, some programming models that can be used for developing .NET apps. Then we're going to talk about like versions, right? So .NET, the words .NET, I think of .NET as an umbrella of languages that have been out since the early 2000s. And so if it's a Microsoft programming language, it falls under the umbrella of .NET. So the umbrella of .NET just means Microsoft built the language, okay? Now, something that's really unique about .NET Core is that even though Microsoft is the quote-unquote owner, it's actually open source. And so to say that Microsoft built it, well, it's open source. So anyone that can make and has made meaningful contributions, this is a little bit unique, right? Because Microsoft used to just be closed source, but then stuff like the Murach stack in JavaScript has these libraries that are vast and very powerful and can do all sorts of stuff because it's open to the whole world, right? You're not limited to your developers at Microsoft. And so like Microsoft said, hey, we're losing ground in the development space because now they're developing these apps not with our software, because we talked about like there's premium tiers in our software, and if you pay for the premium tier, that's an income stream for revenue. And so they don't want to lose ground to these other languages. They want to be, number one. And so, anyways, we talk about versionings, which is bullet number 9. .NET Framework is a version. .NET Core is a version. There's middleware. So that same language that we used last semester of middleware is here. And, defining that pipeline of what method gets called first and what method gets called next. And then we're going to talk about state. Right? We introduced cookies last semester. We were saving cookies on the client to maintain state. Well, there's a bunch of ways to maintain state. And when I think of state, I just think of a variable. Right? How do we maintain data in a variable in a web application because HTTP is stateless by default? So by default, in a round trip client-server response, the app terminates and it kind of forgets all about you, right? I forget everything there is to know about you. So we've got to figure out some different ways to maintain state. We're just going to talk about, there's a bunch of ways to do it. We got Visual Studio Community on our computers and Visual Studio Code, which is what we used last semester. So those are the two IDEs. We will be working on a Windows machine. Therefore, we can use Visual Studio Community because it's a Windows machine. However, .NET Core is both open source and cross-platform. And so that's a benefit of .NET Core, is that you can develop apps using VS Code if you're on a Mac. And that used to not be the case. In prior versions of .NET, it was not cross-platform. All right, then we're going to talk about coding by convention, arguably the most important bullet, because these conventions are the hard rules that I talked about already, and we're going to need to learn those rules for the rest of the semester. Okay, first slide, the components of a web app. This can really be broken down into clients, and clients can come in many forms. That's why you're looking at a client computer, a client tablet, a client smartphone. I mean, we have clients in our refrigerators, we have clients in our cars. There can be clients, but what are universal about clients is that they access it via a browser, right? All clients have browsers, and so that's kind of what makes it a client, is that the fact that it has a browser. Of course, it traverses the internet. The internet is nothing but pipes, if you will. Networking students will tell you all about these pipes. Pipes are really just cables, networking cables connected to routers, routers connected to switches, and it's just a bunch of cables connected by routers. When you connect routers together, public routers, they call it the internet, right? It's just connecting computers together with cables and routers. So your clients traverse the internet to get from point A to point B, from start to destination. The destination is your web server. Your web server has the information that the client is looking for. Okay, so typically, at a very high level, the client is going to put in a URL. That URL is going to resolve to an IP address, and that IP address is the address of the server. Okay, so at a very high level, there's a name. The name is a domain name. That domain name uses the DNS system to resolve to an address. Just like your home address, you're going to route some mail to your home address. You have to have the address. So kind of breaking this down, you have the HTTP, or if it's secure, HTTPS protocol, HTTP, hypertext, thank you, brain fart on that one, hypertext transfer protocol. HTTPS uses, it has all of our methods built into the HTTP protocol to get, post, put, there's a bunch of built into that protocol. There's a bunch of methods to get files and send updates and deletes, send commands across the internet, right? When I think of HTTP, I think of a protocol that allows us to send methods across the internet. Again, you're familiar with, and there's also status codes, right? 404, 401, 500. We talk about all of these status codes and their importance in the HTTP. So there's methods and status codes when you're breaking down that protocol. Then once you get to the server, right? Once you get to the web server, then you have to navigate, well, what's the path to the ultimate resource that I'm looking for? In this case, they're looking for a resource called index.html. And if it's a very simple static web page, the client says, give me the HTML file, and the server sends it back along with the images and JavaScript that basically load a static page. But that's like the most basic, round trip request that can be made. Okay, and again, it responds with HTML. Typically, it responds with CSS. Typically, it responds with JavaScript. And, of course, the images needed, or call it the, the resources or the additional, video files, etc. Okay? But, this was semester 1 stuff. Maybe a little bit more detail around HTTP at this level. But really, all of this is stuff that I think you guys have seen before and should be relatively familiar with. Obviously, you know what a HTML page looks like. You know that HTTP can send GET requests to a host, which is a web server, on via its domain name. The domain name in this case would be example.com. And this is the basis of how the World Wide Web works, right? This is how the World Wide Web has worked since really the early 90s. Okay, the World Wide Web really became popular in the 90s because they started having these browsers. Okay, if you guys want to like really get into like the history of it, it wasn't until the 90s when this blew up, when the World Wide Web blew up. And it wasn't because the first web browser wasn't invented until the early 90s. Prior to that you could like get files back and forth, but it was all via a terminal, a command line. And so the internet has been around for a long time, but it was the combination of web browsers that came together in the early 90s, HTTP, which came together in the early 90s, and HTML that all kind of worked together. Right, that made the World Wide Web, what it is today. And so, early mid 90s. If you talk to anyone that's older and can remember, they were, it was all confusing back then. What is the World Wide Web? I'm sure you've seen some YouTube videos about famous people trying to describe it and how confusing it was. Kind of like cryptocurrency today, right? Most people really don't understand cryptocurrency, and a lot of similarities there between the two because it was a new technology and most people didn't understand it. But that's basically what came together for this all to boom. And really, e-commerce, being able to sell product online was the promise. And here we are today, Amazon.com, one of the most profitable companies in the world. Because they've mastered e-commerce. So HTTP is that protocol. If you have a login system, if you have e-commerce, you want to get that S on there. You want to get that lock on the browser to get some encryption going on across the internet, right? The difference between HTTP and HTTPS is the protocol SSL, Secure Sockets Layer, and it just encrypts the data from point A to point B, from client to server. And it also does some verifications that there's no... SSL also does like licensing, like it verifies that your web server is who they say they are. So there's like no phishing attacks going on. So HTTPS is a big deal. And if you have logins or you have... e-commerce, you want to get that S. You want to work with HTTPS. There's a few more hoops to jump through to get it HTTPS, but they're worth it. And then ultimately, underlying HTTP is a whole protocol suite called TCP/IP. So TCP/IP, as it says there, is a suite of protocols that sends data across the wire on a network. And so HTTPS is kind of like, hey, I want to get a file. HTTP is a set of rules, is a protocol to get and receive files across the World Wide Web. TCP/IP is more like, hey, I'm going to transmit this data from my computer to your computer. And how is that transmission going to happen? Right? So there is a difference between, obviously, HTTP and TCP/IP. But these are the things that we need to be familiar with. Yep.
So with an HTTP request, is that necessarily you are using a browser in order to send the request, and a TCP, you don't necessarily have to be using a browser for that? Is that the...
Yeah, so, okay, so the question is, let me make sure I understand it. So when you're using a browser, you'll be using HTTP. However, to use TCP/IP, you might not need to use a browser.
Okay.
That's the question, right?
Yeah.
That is the premise of the question, and the answer is yes.
Okay.
You are correct. That is a correct either assumption or you knew that, but yeah, that is correct. You can use TCP/IP using, well, like I said, in the early days of the web, you were using, command line, DOS-looking prompts. Or frankly, maybe you were using DOS, Yeah.
Was that like dial-up?
Oh yeah. No, that was the days of dial-up. Really, TCP/IP. I'm curious when that was founded. But like I said, it wasn't until really those three things kind of confluenced together. But yeah, in the days of dial-up connections. But still today, I mean, obviously, still today, we still use TCP/IP. That's what an IP address is. That's true. Okay, so a little bit different. It's just a little bit more complex. If I go back a couple of slides, you see a very simple monitor and one computer. Okay, and and that's as simple as it can be, but in real world, it's a little bit more complex. And so here we have that same client, but we actually have three computers. Now, this is called a three-tiered architecture, right? So you'll hear that term, three-tiered architecture. I don't know if the book talks about it, but certainly this is very normal. Web servers, and by the way, these tiers are only dictated by software. Even though what we're looking at is three computers, that doesn't have to be the case. In fact, those three computers can be one computer. Okay, but the important thing to notice is that each one of these has a different piece of software on that computer. So on a huge web application, like if this was Amazon.com or Facebook or Twitter or whatever, you're going to take the responsibilities across multiple servers. Okay, and so the web server's job is kind of like, hey, I'm going to receive that HTTP request and I'm going to send back responses, and I'm going to initiate, like, hey, you're making an HTTP request, and it's the web server's job to receive the request and send back the response. Okay, and also figure out what needs to be done in between. Now, when you're requesting a file extension of a .html, that is different than requesting a file extension of a .jsx or a .cs, right? If the HTTP request has in it a path to a server-side application, this web server, in this world, it's called Kestrel. It used to be called IIS. Okay, so the new IIS is called Kestrel. The web server, I don't know how to handle this programming logic. I need to pass the programming logic off to another piece of software. That other piece of software is, again, just you would install this piece of software in the application server. In this case, it's .NET Core. The application software, guess what? It might have a database request and say, I need another piece of software to handle, the insert command to insert a new row for a new customer. Okay, so these are just different pieces of software and they have different responsibilities. That's what you need to take out of this. If I were to try and translate this, Express was our web server, right? In the MERN stack, the E that handled the HTTP request. Now, the application server was a lot of the JavaScript that we would write like in the routes. Once Express got us to the route, then we would write the application logic in our JavaScript, right? So it wasn't really its own letter in that example, but the application software that we wrote was ultimately the logic that we wrote was, either in the middleware or in the routes that we just wrote. And then the database server was obviously Mongo, right? And in Microsoft world, that's going to be Microsoft SQL Server. Okay, so in the database realm, your database management systems, the big ones are Oracle, Microsoft SQL Server, Mongo database, NoSQL is another really big one, right? There's a bunch of DBMSs, but those are some of the biggest. Okay, Oracle is really friendly with Java. So like Oracle and Java tend to work well together. Mongo and JavaScript tend to work together. SQL Server and .NET tend to work together. That's your tech stacks, right? These are softwares that generally work well together. So we're in the .NET tech stack. So we're going to be working with normalized databases, and we're going to be working with Microsoft SQL Server. Back to the MVC pattern. So this is the first time you're seeing this pattern. Now you're going to notice that the HTTP request that's coming from the client, its first stop is actually the controller. Right? You might think it's the M because it's the first letter, but that's actually incorrect. When a client makes a request for a .NET resource, the request goes into the controller first. That's very similar to hitting the route in Express. Okay, so in the MVC pattern, the controller is where you find that programming logic. That C# logic, custom logic, if you will, is going to be found in that controller. The model, the M in the MVC, really represents our database. Right? So again, in the MERN stack, that database was Mongo. Okay, so M represents our database. Controller is our C# logic, and the view is the front end. The view is the front end. So obviously in the MERN stack, that was React. Okay, now what's going to be different about this class? What we did last class, I don't know if you liked it or not, but we did horizontal slicing. And what I mean by horizontal slicing is we learned Express first, and then we learned Mongo, and then we learned React, and then we kind of at the end, we tied it all in together, right? But it wasn't until like day 50 that we tied it all in together, or maybe day 60, okay? But that was an MVC pattern. In the MERN class, it was an MVC pattern. We didn't talk about it, but it was. Here in this class, we're doing vertical slicing. Meaning we're going to do it all at once. And then throughout the semester, we're going to learn how to tweak the parts and how to make them better and learn them in more detail. Okay? But at a high level, right, for chapter 1, what do you need to understand? You need to understand, okay, the model is the database. The view is the front-end code, and the controller is the C# custom business logic. Right? The request comes into the controller goes to the model to get the data, and then the model is sent back to the controller to again customize that data however the controller may want, and then send that out the front door to the view. The view then sends HTML, CSS, JavaScript to the front end with the data. So, that's more or less, I think, what I just said. So the request comes in to the controller, gets the data from the model, passes that to the view. The view generates a user interface. The model provides data access, not the data itself, but like the model requests the the model makes a request for the data access, and the custom business logic in the So because there's different pieces here, they talk about the benefits as if this is a sales approach, why should you implement the MVC pattern? And you can go through this, you can break it up. Hey, you guys work on the view. You guys are working on the front end. You guys are working on the data. You guys are working on the model. You guys are working on the controllers. So separating out responsibilities across a team. Again, anytime you break out code into different pieces, it makes it easier to test. Smaller code chunks are always easier to test. Swapping out one component for another component and making the app easier to maintain. But it does require a learning curve, I would say, to set up. So here we are on slide 12. Maybe I take a quick break from that and let me just install an MVC web app here. And I'll take you through the new project. And so here, fresh install of Visual Studio Community. I've logged in, right? So haven't done anything on this computer yet in VS Code. So I'm going to create a new project. Now I did select ASP.NET on the installer, okay? And so there's different options here. Now, Blazor is another technology from Microsoft that's a little bit newer. Like Blazor, I want to say came out a year or so ago, and is really doing some interesting things that we should explore in this class, but that's not what this class is on. This class is on ASP.NET Core, specifically the word core, with Razor Pages. And Razor Pages is just a syntax for the front end. Think of Razor like the word, React. Like it's kind of the technology for the front end. And this looks just like to be the same without Razor. But this book, and everything we're going to do in here is Razor. So you can kind of scroll through. Now, this core web app does not say MVC. So I'm actually, that's why I kept scrolling, because I was like, I don't think that's right. ASP.NET Core web app model view controller. So, of course, we could filter it to C#, which is a good thing to do, by the way, because there are other options on these templates that you might accidentally select if you don't filter by language. And let's see. I'll keep all platforms and project types. You could say web or web API. So there's that. Anyways, that we had it selected right. So here's ASP.NET Core Web App Model View Controller. And of course, once you select this for the first time, it'll be under the recent. And so it'll be easier to select in the future. If you remember Visual Studio, you've got a solution. And in that solution, you can have multiple projects. And so the default location on the hard drive is fine for this. But I'll just call this solution demo chapter 1. And my project will be, yes, sir.
If we didn't sign in from before, should we sign in before we start this? Or else it's just going to save under a user instead of our actual profile?
Okay, so the location here, the reason why, this is the location on my hard drive. And so it's separate from signing in on Visual Studio. Yeah. And so my solution name is Demo Chapter 1, and I'll just call this I'll just call this lecture demo, just to name it something different. And I'll click next. Now it's really interesting that you can, remember user authentication and how complex that was to get that integrated, We did it very custom, right? We built a custom authentication system using oh gosh, why can't I think of it? That would encrypt our passwords. Thank you, bcrypt and encrypted our passwords. Let's use authentication system with individual accounts. And so again, this is a very, very different world. Now, benefits, right? Benefits of having an authentication system built in. Well, the problem with everyone building their own authentication system is you're going to have good ones, you're going to have bad ones, and everything in between, right? When there's an authentication system built into the framework, you're going to get good code. And it's going to be fast. Probably won't be perfect, but it should be fast. It should be secure. There's a lot of advantages to not custom building something. Why rebuild the wheel, right? You just give me a good wheel and I'm going to use it. Okay, and built in here, enable for HTTP. Dockers for deployment. I'm not too worried about that right now. Let's just hit create. By the way, .NET version 8, I could have took a look at that. These tend to take a minute to spin up because, going back to the PowerPoint, they talk about requires more work to set up. And there's a lot of files with this default template. And even on my computer, it's pretty fast. But look at this entire folder structure over here, right? And we're going to get into this folder structure, but I can start this without debugging and kind of see what's going on here. You can see I've got a views folder, I've got a models folder, I've got a controllers folder, I've got this thing called areas. A lot of things that you need to hide behind permissions, you put in this areas. This project to configure for SSL. Would you like to trust? Don't ask me again. Yes. You're about to install a certificate again. This is all because we selected that HTTPS. So that complicates things because I checked that box, but I just say yes and don't tell me again. And it takes a minute to boot up. But here we go. We've got a very simple template, if you will, Bootstrap built in. I've got a register button here where I can register hello world, confirm hello world, click on the register button. Oh, doesn't like it. Hello world 1, capital A, capital H, E-L-L-O, world 1, capital H. Got a little validation. Can't type. Let's see if I meet the requirements. Whew, H3LLO world 1. H3LLO. Okay.
You have to have one non-alphanumeric character.
Like percent or something.
Okay, there it goes. The first time that you actually register a new user, apply existing migrations or migrations that have been applied, credentity, apply migrations. It does spin. First off, I remember it taking a while. I don't remember it crashing. But we might need to run, very much like on Node, we had to run like an install npmi to install dependencies. We're going to go ahead and run this command to update our database. So let's refresh. I might need to run this command at the terminal. Okay. Register confirmation. Normally this would be click here to confirm your account. Thank you for, okay. So I had to click that button. It worked. Let's go ahead and log in. Okay, yeah. Hello, yeah, Gumstead. Pretty simple. Again, first time we're seeing it, and it has changed since last year just a little bit, so that threw me off. Hi.
Hi. Everything going okay?
I think so. How's it going? Okay, so yeah, it has changed a little bit, but basically, hey, we got a built-in check a box. You got some HTTPS built in. We've got user authentication built in. And if I were to close this and look at my databases. So I need a new window here. I don't see, let's go to view and let me go to my Object Explorer. We could see my databases here. Here's my database that was just created. So this spun up a database for me. And if I look at tables, here's my users table. And if I view the data in my users table, there you could see my user ID, my username. Different world, huh?
Did they encrypt the password?
Oh, yes, it encrypted the password. Password hash. Right there for you. Different world. But pretty neat. Within a couple of clicks to kind of spin something up with a authentication system. So yeah, and getting back to the original intent here, there's more to it, right? In the sense of like there's a little learning curve that we got to get used to. There's convention that we're going to get used to. There's a lot going on here. A lot going on behind the scenes. Let's see. All right. To talk a little bit about the old technology, not going to spend a lot of time here. Web forms were literally drag and drop. You built web forms not with HTML, but with a toolbox of tools, similar to like, remember you guys on your desktop apps, you were dragging and dropping? That's how you built the interface. They did that for web forms. So you could drag and drop controls, and that was a technology that made what they call rapid application, rapid application development. Like it really did. It kind of sped things up. And so I use these tools. I actually built some stuff on these tools a long time ago. It's old, but that was around for a long time. And so even though we sit here and I like, yeah, it's old, it doesn't mean you're not going to see it. Like a lot of companies, if it's not broke, don't fix it. And so I would tell you specifically, the easy target here is the government. If you go work for the government, you see a lot of stuff built in .NET, and you see a lot of old stuff built in .NET. And so I've had graduates go work at, for example, Scott Air Force Base and have to work with this older technology. Which by the way, the government as an institution, one thing I haven't said yet here, but is worth saying and is worth you guys hearing. As an organization, Microsoft is kind of trusted by corporate America and generally trusted, by big institutions like the government. Okay? So when it comes to like, okay, hey, we need to implement a technology stack. Should we implement MERN or should we implement .NET or should we implement, like a PHP thing? The advantage that Microsoft has is that they've been around and generally they're a little bit trusted. And I would also say most corporations are already bought in to the ecosystem. Okay? Now, you all as individuals, you might be Apple products, you might be Android products, but generally speaking, you're in an ecosystem, right? Generally speaking, all your products are one or the other. Why is it? Because once you're in the ecosystem, it's easier to just stay there. Okay, so corporations, well, they might have Microsoft Word, they might have Microsoft Office 365. They already have a subscription for Microsoft products. So when it comes time for their developers to develop on a platform, they're like, well, we're already in the Microsoft ecosystem. Let's just keep everything there. So I would say that's probably one of the main reasons why .NET has really been so popular, because again, corporations are already in their Microsoft ecosystem, right? They're already bundled saving on software because they got Office 365 and they got OneDrive and they got, so let's bundle now the developer tools into this ecosystem and save, versus saying, okay, okay, that's part of the popularity behind the .NET framework. Now, again, the book goes through and it really does a good job, I think, of talking about the versions here. So there was what was called ASP.NET Framework, right? Which was proprietary, built by Microsoft, and only runs on Windows. So that was kind of around in the early 2000s. Then Microsoft made an MVC version. So there were, at one point, there were web forms, and there was this model view controller that we're going to learn all about using this pattern. But it was still proprietary, and it was still Windows only ASP.NET Framework. Well, it was still built by Microsoft, proprietary, not open source, right? So it wasn't until Core is the version that went open source, and Core is also the version that can run and be developed on Windows, Mac, and Linux, right? So when you see the version of Core, that's just really the latest and really has been popular. Now, again, there is this technology that Microsoft is now kind of getting hyped about, which is called Blazor, okay, which I do think is worth experimenting with and getting familiar with, but that's not what this class is on. I did mention already that Razor Pages, this is really front end. When you say Razor Pages, it's like, hey, you're going to notice that this is on the front end, and it allows you to basically have a data type for your pages. And so, for example, if your page is a list of students, like you got a page to list all of your students, this Razor syntax allows you to say, hey, I want you to use this student model to understand what the data is on this page. And so very much how in C# everything has a data type, right? In C# everything has a data type. Your data type can be students. Razor Pages, it says, hey, the data type for this page on the front end is a student. So that, you could do student.firstname, student.lastname, and your front end understands a little bit about the data that's in the model. Okay, so really a Razor Page is getting that typing, if you will, in C# into the front. Right, so over here you have the left, you've got the .NET framework, and over here on the right you've got .NET Core. Again, kind of multi-operating system here. MVC and Razor Pages, obviously we're working over here with the latest stuff. There's just like you had middleware before to authenticate and authorize users, right? We actually implemented middleware to do those things. One of the middleware was like has permissions. Remember that? Has permissions or has role. Those were middlewares that we implemented. These that can short circuit requests, right? Like you can't get to this resource if you don't have a certain permission or if you're not logged in. right? So that's all that this slide is showing. That exists over here too. We can write middleware or implement middleware that if you don't have, certain permissions, if you don't meet our checks and bounds, you're not going to actually get to the resource at the end of the line. Which is, in this case, the routing middleware takes you to the route where you start, getting the data and what have you, making this useful. Right, so here's kind of like a short circuit request, right? So the only difference between these two slides is like, hey, yes, you're a user, but you're not authorized to hit the route, right? And we'll implement middleware to do that. So just like before, right? What could middleware do? It could modify the request and the response object. Look at this bullets, right? Just like in JavaScript, middleware can edit the request object and edit the response object. Just like we did before, we added properties to our request object or our response object. Rec dot body is there, but then I think we added rec dot. I forget some of the properties that we added based on our middleware. Okay, long story short on this slide, HTTP is stateless, right? We're going to talk about cookies. We're going to talk about this thing called temp data. We're going to talk about these different ways to remember who the user is. Are you logged in? What are your permissions? Because again, what happens is a client says, hey, give me a resource. The server responds with that resource, and really the app ends. Like, I think that was something that you got to realize is that if the app starts on the request, think of like starting the process on the request, when the response goes out the door, the application ends. Like the application's not running anymore on the server. So it forgets who you are, who anybody is. So you have to have a way of maintaining state. There's ways of maintaining state on the client. There's ways of maintaining state on the server. Of course, we're going to learn all the ways. Okay? But again, I think the easy thing to conceptualize, and when you hear the word state, just think of a variable, right? A piece of data, right? So, the last couple of slides here, as we talk about the features of Visual Studio, if I open up my Visual Studio here, there's basically, just like there were before, there's two ways to start your application running. There's start without debugging. Control F5, this is faster. This is my preference, unless I'm actually debugging. If you're debugging and you want to hit a breakpoint, because guess what? We're going to use breakpoints, then you're going to start with debugging. Right? Another thing to point out here is that you can change the protocol, HTTP or HTTPS. Okay? So over here, James, over on break, he said, hey, I'm on wireless right now, and my browser settings aren't very happy when I'm doing HTTPS, and I can't even get my page to load. So is it okay that I change this to HTTP for now? And the answer is yes. This is not production. This is just learning. So by all means, you can change your protocol here. You can also change your default browser for the project, right? So if you want Chrome to be your default, or Firefox, or Edge, you can change this. If you want to set this on a more permanent basis, I think you got to go more. I don't know that this is a permanent change, right? But these are the normal controls that we're working with. There's a hot reload, and so this button, and we'll get into this hot reload means you make a change to your code, and it automatically shows you that change to your code in the browser. So you guys have grown to like that feature. or you probably will grow to like that feature because you've seen it in different, in different capacities. You've seen this hot reload being used. I do want to, because I did check the GitHub Copilot, and honestly, I haven't used Copilot in here. So I'm kind of curious. There's my GitHub Copilot. It is checked. This extension is already installed. So I'll be kind of now, because I haven't authenticated with GitHub. So if I go to my account settings, okay, so here it does kind of recognize my user account. So I'm going to re-enter my credentials. You guys are probably going to have to do this. Success, your author is successful. You can now return to Visual Studio. So obviously I was already logged in over here at github.com. So cool. And now it looks like I'm authenticated to GitHub. And I should have, just like we set up last semester, we had Copilot as a student. You guys should have Copilot, I believe, eligible to you. I haven't really used that over here. I don't know what that looks like. If I were to just open up a controller. So here's my little C# code. So here's some controller. I don't know. Okay, to enable GitHub Copilot, add GitHub account. Sure. I already did. Let's do this again because that seemed buggy. Okay. Well, I already did that. Okay. I'm going to have to figure this part out because obviously that seems to not want to work. No big deal. So that's a little bit more about Visual Studio. Again, we'll be using it all semester. You guys know the tool. Just got visuals. We got IntelliSense, which was the code completion before GitHub Copilot. We got built-in debuggers, and it runs everywhere. Okay. This, again, I kind of, during the objectives, I said this is probably the most important piece of this lecture, is understanding the conventions that we're going to be working with all semester. And so, here's what I'm going to say when I'm looking at this slide. Look at our file names. We got homecontroller.cs. We got under our models, we got product.cs. And under our views, we have CS.html. Well, a controller is just C#. It's just a class. If you guys remember a C# class, that's what a controller is. It's just a class. Let me open up a controller. This is my home controller. Public class home controller. Okay? So if you kind of remember classes and objects from C#, a controller is just a class. A model is just a class. Right? So remember classes and objects. A controller is just a class. A model is just a class. If I go to a view, well, the view is a little bit different. It's got CS.html, but you could probably guess the CS is like C# source code. You can write C# and you can write HTML. So what are we looking at here? Well, we're looking at some HTML. And up here, we've got a little @ symbol where we can write a a little bit of C# where we're adding a property equal to homepage, storing it in this thing called view data. Homepage blah blah. And if you had to guess where that title is going to go, I'm guessing you could guess. So let's boot it up. Homepage blah blah, right? So don't let these files intimidate you. They're not intimidating. They are just C# classes mixed with a little bit of HTML when you're talking about a view, right? So you can write C#, you can write HTML. Don't let the folder structure or the naming intimidate you. So what are these rules? Well, it's you can kind of pick up on the conventions, right? First off, all your controllers have to be in a folder called controllers. Okay? Now you can also have subfolders. So if you want to have your controllers in subfolders inside of that main root controllers folder, that's fine. But basically, pretty simply put, all your controllers have to be in a folder called controllers. Okay, same thing with models. Same thing with views. So very, very simple, 3 easy rules. Controller classes go in the controllers folder. Models go inside of models. Views goes inside the views folder. Okay, then we have static files, right? Static files go inside of www root. You're also going to notice the naming convention of all of our controllers have the suffix controller. Home controller, product controller. So there's a file naming convention, and again, pay attention here because these are rules we will have to implement all semester long. So your controllers have to have the suffix, the latter part of their name, controller. Now, if I open up the home controller, obviously the class name has to match the file name, right? So the file name is home controller, capital H, capital C. The class name is home controller, capital H, capital C. And of course, what does the colon mean in C#? You guys remember this? What does the colon mean for us?
It's like it's shared.
Close.
Inheritance.
Inheritance. Thank you. Yeah, inheritance, right? So, yep. So we're inheriting methods and properties that are public or protected in nature from the controller class. So yeah, we're showing an inheritance relationship here. All right, let's see. Now, besides the naming of controller, notice that the models. Yeah, James.
When you said naming like a class in a folder the same thing, was that like just your rule, or will it not function?
The class and the file name, and that's a strict rule. That's a strict rule. Yeah, you wouldn't want to name this class anything different than the name of the file. Okay, by the way, this file extension for the view, if I go into my views, CSHTML, that's that Razor syntax that we talked about. That is the file extension for a Razor view, CSHTML. Okay, I think we just covered all that. Yeah, we did. Now I know we got to review our C#, right? But do you guys remember auto-implemented properties? That's what we're looking at here. We're looking at a class called product with 3 auto-implemented properties, a product ID. Now I'm going to talk about product ID. Again, if you guys it's the end of a lecture. I know it's been a long time, long lecture. All right. But this line right here, where my mouse is, public int product ID. That's your primary key on the database table for product. So we're going back, we're using a lot of language here that we haven't used in a while. Notice the convention is what? It's the class name followed by ID. Now in this case, both the I and the D are capitalized. You could do, the D could be lowercase and that would still work, but it has to be product ID. Okay? And what that equates to is a primary key column in the database. Remember what a primary key does in a normalized database. A primary key in a normalized database guarantees that each row is unique. In other words, no 2 products are the same. Right? So primary key columns are fundamental to normalized databases. Mongo wasn't normalized. You didn't have to have primary keys. We did because it's still not a bad thing in most cases. Most users had a user ID, right? But it's not a hard requirement. But in normalized databases, to get them normalized, quote unquote, the process, you need to have that ID. So if you make a model that doesn't have a ID, I would anticipate errors. And again, what's actually going on here, there's a lot of things, there's a lot of fundamentals in C#, that's going on behind the scenes with these auto-implemented properties. And oh, by the way, setting up like a default value of an empty name, so on and so forth. But we'll get into more of the fundamental C# over the next couple days. Okay. Now, to break down this slide a little bit, and again, this is probably we talked about inheritance, that this product controller inherits from a parent called controller. And if you're looking at this class, it has 2 methods. These methods, another term that's used in the MVC world, these methods are also called actions. So when a controller has methods, these are often called actions, and they return a data type that is referred to as an action result. So this keyword return returns a view, which a view is classified as an action result. So it's kind of, just a little bit of the language there. But what I want to point out here is that this actually applies into the routing. Okay, if I jump ahead and I say, look at this slide, I say /product /detail. That route in the URL would equate to the product controller. So what I'm going to do is I'm going to look at the product controller and I'm going to look for the detail method that takes one input as an int. So I'm going to look for a detail method that has one parameter as an integer inside of the product controller. Okay, so this is routing in .NET. Now let me back up Here's my product controller right here. And here's my detail action or method that takes one int as an ID. So this is routing in .NET MVC. Okay? All of that is convention. All of that is convention. The product controller is how I get the /product in the URL. The detail is the name of the method. This is the identifier of the method. The method is called detail. And then the third parameter is the ID, or the input, the argument, if you will, into that method. Okay? Now, if I wanted to get a list of products, I don't have to provide that third argument. It's just /product/list. And then what do? I call my database. I get the products from my database. I store it in a list of type product called products, and I send my products to the view. I don't know about you, but this is, to get back into C#, I'm excited to do this. Hopefully you guys are kind of like, okay, good. I miss my C#. Okay, now, notice in both my methods, I'm sending some data from the database to my view. Notice my file name is detail.cshtml. Again, that's convention. The convention is, hey, I've got this detail method, so when I return to a view, it's going to be the detail.cshtml. So inside of the view folder, you find this file. This file is a Razor view, which means, take a look at that first line, at model product. That means our HTML has a model. And that model, has an ID, has a name, and has a price. So when I say at model ID, at model name, at model price, well, that model ultimately is a product. Everything is strongly typed. It's a beautiful thing. Makes me happy. Strongly typed. Okay? That's how you go to that route. It hits the database. It sends it to a view. The view's showing me a bootstrap table. If I look at that bootstrap table, it's got some bootstrap classes on it. Table class of table bordered, and table striped. So we're applying bootstrap classes in our model. And down here, we've got an anchor tag with a special attribute called an ASP controller, ASP action, that says home. Right? This says, hey, when I click this button, this bootstrap button, it's going to take me to the home controller. And the method inside of the home controller is the index method. So when I click this link, it's going to send me to a specific method inside of a specific controller. Okay? All of these have to, like your Express, you got to instantiate an instance of your Express app, right? Here, remember, var app equals builder build, and then here we can, this file right here, the program.cs, is the equivalent of this is our app. This is where our app begins. And this is where we can install middleware. And so, yeah, the program CS is kind of like, wow, that's a loud, what was that? Here's program CS, right? And this looks a lot different than what the slide had because I clicked a few extra buttons. But this file right here is where you can, like I said, install middleware and, make application-wide configuration changes. And so that's the program CS file. A couple things to point out here, as I think a lot of this is just default settings, and so you're going to see the app.map controller route. Everything that I just explained says, hey, your default routing is a pattern that is the controller name followed by an action name followed by input parameters. This is all customizable and can change, but this is the default routing in the .NET world. Okay, obviously app.use routing, I don't know what it would look like if you were not to use routing, so of course that's a hard requirement. And then, adding controllers with views, again, I just view this as boilerplate stuff. Yes, we need controllers, we need views, it's MVC. Like, your app needs to have these lines of code for it to work how it should. But yeah, think of this as a configuration file. Okay? And because of this pattern, because of that pattern, again, you got different routes. The home route will by default take you to the index because it said right here, the default action is index unless specified otherwise, right? So if I go /home/about, it's the home controller with the about action. Product controller list action, product controller detail action, right? What's guaranteed to happen is, this convention is strict, and you guys are guaranteed to make mistakes because it has to work this way out of the box, right? So hopefully you got something out of that. Hopefully you got at least familiar with MVC, and that kind of marks the end of that lecture on day 1.